Okay, welcome to the 2-5 Mixed Review Part 2. I decided to break them up into two separate videos so it wouldn't be too much for you to have to click through to find the problems that you missed. So let's take a look at problem number 5. It says this: given angle TPR is 42 degrees. So let's see, I go from T to P to R, and that is of course going to be 42 degrees. Now let's go ahead and start using our math here. We know that, you know what, I'll use some purple here. We know that we have these two congruent sides, so that means that this is an isosceles triangle, and this is the angle where those two congruent sides meet, so it must be the vertex angle. So what's our standard operating procedure for when we have the vertex angle? Well, we'll do 180 minus 42, which will of course give us 138 degrees. And now remember, these two base angles are actually congruent to each other, so we can divide this by 2. Now it turns out that 138 divided by 2 is going to be, 138 divided by 2 is 69 degrees. 69 degrees. 69 degrees. And I'll even write it right there, 69 degrees. Okay, now it says find the measure of PTR. So let me use a different color here to really denote that. So we're going to P to T to R. So we've got like this portion right here, but we also need this portion. Like how big is that angle right there? Now, get ready. I'm going to use a really slick trick that I want y'all to memorize. I see that for this triangle that I'm putting in red, this angle right here and this angle right here, these are the two remote interior angles to this one exterior angle right here. And so think back to the exterior angle theorem. We know this. We know that angle, I'll just kind of abbreviate here. We know that angle T plus angle R is equal to just, I'll call this one angle S right there, angle S. We know that these two have to add up to that. And so if angle S is 69 degrees, and wait a second, these are base angles that are congruent, we can just do 69 divided by 2. You got 69 divided by 2 will in fact give us, let me redo this, 34.5. So that will be 34.5 degrees, and this over here will be 34.5 degrees. Now guys, all you have to do is add up those two things. If you just do 69, that very first angle, plus 34.5 degrees, you're going to get 103.5 degrees as our answer. And so we can say this. We can say, you know what? Angle PTR is equal to 103.5 degrees. Alright, let's go ahead and move on to example number 6. Okay. Here in example number 6, it says find the measure of angle AEC. So let's see, from A to E to C. So we want to find the measure of that angle right there when given angle, let's see, angle DAB is 57 degrees. So if I go from D to A to B, well, I know that that is 57 degrees. Switch to a different color here. And if I talk about angle BCD from B to C to D, well, I know that this angle right here will be 31 degrees. Okay, a couple of things to note. Thing number 1, from this angle to here and from this angle to here, what do I know about these two angles that I just did in green? Well, I know that they're both congruent. Why? Because they're both on the interior, they both fall in between these two lines, and not only do I know that they are on the interior, I know that on this transversal, this one is on the left, this one is on the right. So what I have are a pair of alternate interior angles, and I know that those are congruent. So that means that this right here must also be 31 degrees. Okay, now that I have two angles of a triangle, let's go ahead and switch to a different color here. Let's go ahead and switch to, I don't know, this nice purple. If you look at this triangle, what do you notice? you notice that we have 57 degrees and 31 degrees. Well, we can actually find this missing angle right here. We know that all three angles of a triangle, 57 plus 31 plus our mystery angle, all have to add up to 180. Well, what is 57 plus 31? And that's going to be 88 degrees. Okay, so we can subtract 88 from 180. Now, I don't want to make any silly mistakes here, so let me just go ahead and do that. 180 minus 88. And that's going to give us 92 degrees. So I know that this angle right here is 92 degrees. Well, wait a second. The angle that we're searching for lies on a straight line. So I can straight up just do 180 minus 92, which gives us back to 88 degrees. So it turns out this angle right here is 88 degrees. The other thing that you could have seen, and I just want to show you this because I want you to have all the options. If you look at this triangle, I'll redo it in yellow. This right here is the exterior angle. Oh, that yellow is kind of terrible. This right here is the exterior angle, and all you had to do was add up the two remote interior angles, and you would have gotten the answer. So the answer is 88 degrees. Alright guys, let's move on to example 7. Okay, for example 7, it says write a congruency statement using the exterior angle. Well guys, we've used a lot of exterior angle theorems on this one, so let's just kind of label it. Let's say, you know what, here is our exterior angle, and our exterior angle is angle DCB. Now notice, I'll switch colors here, that this angle right here in the red, angle DAC, is right here. And let's go ahead and use one more different color. Let's use this nice green. If we go right here from A to D to C, I use two arcs right there. Well, we're going to have angle ADC. Well, we know that our two remote interior angles have to add up to be our exterior angle. So we can just say this. Angle DAC plus angle ADC is equal to, or is congruent to, angle DCB. Alright? And there is your correct statement for this problem. That was nice and easy. Let's move on to our 8th problem. Okay, here is problem number 8. Guys, I'm going to be honest. This is probably one of the hardest problems that I've never seen DISD even attempt to tackle in an ACP. But this is in their sample problems, and it's kind of a fun one. So let's go ahead and start tackling it. It says, in the figure shown below, octagon FGHJKLMN and pentagon AEIOU are both regular polygons. Okay, so I know that this polygon is regular. Well, why is that helpful? Well, that allows me to use this formula, n minus 2 times 180, and I even want to show you all the extension to this, where you just also divide by n. If I want to figure out how big are each one of these interior angles, all I have to do is use this formula. So let's see, we know that a pentagon has 5 sides, so I can do 5 minus 2 times 180 over 5, okay? And we know that 5 minus 2, oh, let's just bring it up here, is going to be 3 times 180 over 5, and we know that 3 times 180 is 540 over 5, and guys, 540 divided by 5 is 108 degrees. So check it out. I know each one of these is 108, that's a weird 8, 108 degrees, 108. Okay. Now, the key here, I want to show you all the trick though. The trick, we're searching for angle HJZ. So if I go to H to J to Z, we're looking for this. The key is always to move from one shape into the other. And the best way that you can do that, if you ever have it, is on a straight line. So let's start working this way. You know, we're going to say, okay, here I have a straight line, and this angle is 108 degrees. And we know the angles on a straight line add up to 180. So we can do 108 minus 180, which will give me 72 degrees. And here I can write in 72 degrees. And I'm just kind of trying to squeeze it in 72 degrees. Now from here, guys, also notice we have this 41, and we have that angle right there. Well, what do we know about three angles of a triangle? Three angles of a triangle add up to 180. So I can say this, it's just switching colors. I can do 41 plus 72, 41 plus 72, and that will, of course, give me 113 degrees. I can then do 180 minus 113, and I will get 67 degrees. Okay, so now we have that angle right there, 67. Now I said one way to get from one shape into the next is through a straight line. The other way is going to be through vertical angles. So look, if this is 67, then this must be 67. Alright, whenever we have these two lines crossing, if this is 67, that must be 67. Okay, now this is kind of hard to see, so let me do this real quick. Just kind of delete that. And let's say this. What we really have is we have this triangle HZJ. And I'm going to draw that right here. I'm going to draw H, Z, and J. So I'm just redrawing that triangle, redrawing it right here. And we know that this angle right here was 67 degrees. And we want to find, let me switch to a nice little red here, we want to find that angle. Well, the problem is we don't know that angle. Okay, so I want y'all to go back over here to this nice little hexagon, or I'm sorry, octagon, because it has 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to use the same formula that we started the problem off with. We're going to do 8 minus 2 times 180 all over 8. Well, I know 8 minus 2 is 6. 6 times 180 over 8. Well, that will give me 6 times 180. Let's see. This one I'll use a calculator for. I think it's 1080, but let's try. 6 times 180. Yep, that's 1080. And we'll divide that by 8. And that should give us 135 degrees. So I know that this angle right here, using a trillion arcs, because we've talked about so many different angles, is 135. Well, guess what, guys? That means that this angle right here is that 135 degrees. Now, here's what I'm going to do. I'm going to clear this off to make this nicer and neater. So pause the video, finish taking any notes that you need. Okay, and notice, now here I've taken this triangle. So here's HZJ. So here's HZJ. And we found, before we left, that this was 135 degrees. So all we have to do to get into this angle right here is do 180 minus 135. And of course that is going to give us 45 degrees. Okay, 3 angles right there, 45 degrees. And how do we finish this out? Well, we know that any 3 angles of a triangle have to add up to 180. So we can do 45 plus 67, and that'll give us 112 degrees, which, once we subtract from 180, we'll have our answer of 68 degrees. And guys, that means that our answer, HJZ, is 68 degrees. I know that is a beast of a problem. Thank you for sitting through it. I hope that helped. And if you have any specific questions on that one, please reach out to me. Anything that you didn't understand, whastings@dallasisd.org. Alright, thanks guys. Y'all have a great weekend.